Hello students, this is Mr. McAllen, and today we're going to go over, again, how to use numerical, algebraic, and graphical models to solve problems. We're going to focus on one problem in particular. It's this problem which deals with a cubic function, and we're going to first solve it algebraically using traditional methods. So as I do that, remember that there are graphical ways as well as numerical ways to find the answer to this. So I'm going to bring all the terms over to the left-hand side, set it to 0, and then I go through my traditional factoring routine. I'm going to take out the greatest common factor, and now I'm going to factor the trinomial, and I'm going to think for these three terms, what multiplies to give me negative 60 and adds to give me negative 11, and that's going to be negative 15 and 4. I'm going to break up my factors, and if you want to use, so I have x out in front, I'm going to have 6x squared minus 15x, that's from that 15 part, plus 4x, that's from that part, minus 10. And now within these four terms, I'm going to do grouping. So I'm going to group the first two terms. I'll just show that in red. And the second two terms. Taking out the greatest common factor, I've got 3x coming out. I've got 2x minus 5. Plus, I'm going to factor a 2 out of these. And that'll leave behind 2x minus 5. And now I know my factors are going to be x times 3x plus 2 times 2x minus 5. Set that all to 0, and then my roots are going to be, from this part, x equals 0. From this part, x equals negative 2/3 when you set that equal to 0 and solve. And from this part, I'm going to have x is equal to 5 over 2. Solving this graphically is going to require using a graphing tool like a graphing calculator or something like Desmos. So I'm going to use Desmos to solve that and hopefully come up with the same roots. So I'm just going to pause the video for a second while I get Desmos running. So I'm back, and I just got Desmos up and running, and I put in the polynomial that I was trying to set to 0 and factor and solve. And I found that the three zeros are at negative 2/3, 0, and at 2.5. So graphically, we could see that we can find a solution that way. The other way to do this is to do this problem numerically. Now that would require the use of a graphing calculator. So we'll put that function into the graphing calculator. And we'll put the equation in as 6x squared minus 11x, sorry, this should be 6x cubed minus 11x squared plus, or I'm sorry, minus 10x. Now the numerical way to do this is to look for a sign change when we plot out a table of values. So what I'm going to do is I'm going to go to my table settings, and I'm going to make sure that the graphing calculator is set so that it starts at 0 and that it increments by 0.1 units for every as it increases. Now you could change the increment on the table and it's going to automatically fill out. Now the good thing about this is you can numerically see on the graph at 0, when I go to 0.1, my sign goes from a 0 to a negative sign. So I would go backwards, and as I go backwards I see that as I look at the x values increasing in value, I see that my y values are all positive, then all of a sudden they switch to negative. And when a function switches from positive to negative, that indicates the presence of a root or a solution. So as we go, so we know we have a 0 at 0. So numerically, I'm going to keep scrolling down until I see the sign change back to 0. So as things keep going up and up and up, as you can see here, the table values for the function have just started changing from going all the way down to negative like 19. Now they're coming back up, and I'm hoping that as they're coming back up, they're heading for a 0 value. And that indicates that at 2.5, I have a 0. Now I know I have my other 0. It's a negative at negative 2/3. But as you look at this function, you see how the values are going up and up and up. So that would indicate that maybe I should try my values. I should look on the other side of x for the values. And this is a numerical approach using a table to display values of the function, looking for where that function would cross through the x-axis and switch sign from positive to negative. And I just passed what that 0 would be because I was moving too fast. So as you can see here, my table indicates that I have a 0 somewhere between negative 0.7 and negative 0.6, hence giving you a numerical idea or a numerical solution for the problem. I hope this numerical method helps you understand why the zeros are where they are in the graph, and of course we should understand the algebraic method. In the next part of this video, I'd like you to just take notes so that we don't have to take time up in class tomorrow taking notes on the problem-solving process. A few important areas to consider. You first should always understand the problem. After you understand the problem, you should devise some sort of a mathematical plan or a plan to come up with a solution. You'd like to carry out the plan, and the most important part is looking back at your solution to make sure it makes sense. In a more detailed structure, Finney, DeMana, Waits, and Kennedy, the writers of our book, came up with steps, and they also suggested different techniques on each in-between step. For example, when they say understand the problem, they're talking about reading the problem as it's stated, several times if necessary. Understand the meaning of each term used. Restate the problem in your own words. Discuss it with others in groups. Identify clearly the information that you need to solve the problem, and go and find the information that you need that may not be given in the data. Copy down these steps, and tomorrow in class we're going to talk about this problem-solving approach. So pause the video here where you see steps 1, 2, and 3, so you can copy this down. And then copy down step 4 as well. I'll be asking you some questions in the form as far as what the steps in the problems are, and I'll be checking your notes tomorrow to make sure that you copy this down in your notebook. I hope this video helps, and I look forward to hearing your comments and talking to you tomorrow in class about this.